If you open any internet browser and search on 3D printing, you can find countless items, large and small, that went from idea to reality with the help of 3D printing technology. What you may not know is the Marine Corps also uses this technology to provide organic logistics, supply, and sustainment solutions to the fleet. Marine Corps Systems Command's Advanced Manufacturing Systems team supports the service's goal to employ advanced manufacturing throughout the Marine Corps. Once referred to as the Corps' on-call nerds by our guest himself, the AMS team fields the Marine Corps additive and subtractive manufacturing programs of record, issues policy, certifies and stores files of 3D printed parts, and maintains a help desk to assist the operating forces and SysCom programs of record in all things advanced manufacturing. Joining me today is Major Matthew Audette, Advanced Manufacturing Systems Team Lead. Welcome, Major.
Happy to be here.
Tell us a little bit about yourself, why you joined the Marine Corps, and how you came to work here at Marine Corps Systems Command.
Yeah, absolutely. So I come from a family of Marines. It's a joke. Some people tend to frown at this, but with things you explain, why are there so many Audettes in the Marine Corps we don't learn from each other's mistakes? And so at any given time, there's usually about 8 of us floating around. That was one of those things where, with a family of Marines, I knew that as I grew up, I had to do something to put food on the table, but I really didn't want to work for, I want to work for a cause, not a dollar for somebody else's profit. So that drove me to service, and then with the family of Marines, that really pushed me in that. I grew up with the history of it, and it appealed to me. So I'm a combat engineer by trade, and then how I landed at Marine Corps Systems Command is through the Commandant's Career Level Education Board. I got selected to go to Naval Postgraduate School to study electrical engineering, and while I was there, there's a maker space. So it's essentially a workshop for tinkerers. And I'm a tinkerer, I think, with my hands. And in there was a bunch of 3D printers. These are great. I want to use these. How much does it cost? I said, well, they're free, and the line must be out the door. Well, actually, nobody uses them because we don't think anybody knows how to use them. So I told them, well, if you give me a key to this lab, I'll teach a quarterly class on intro to 3D printing. And now all of a sudden I got access to 3D printers 24 hours a day. And so while I was teaching this class on 3D printing, some folks said, hey, there's setting up a 3D printing team over at Mark for Syscom to look for people. And at that point, I didn't know what Syscom did. All I heard was, hey, if you go there, you can 3D print. So absolutely.
That's all you needed to hear.
That's it. That's how I landed here.
Okay, well, we're glad to have you, and I'm sure the fact that the Naval Postgraduate School is in, Monterey, that didn't impact any decisions. So
right, exactly. Yeah.
All right, so let's dive on into the deep end of the pool. Explain to us a little, what is advanced manufacturing? Is that the same as 3D printing or additive manufacturing? What are the differences?
You'll find that there's no one set term for advanced manufacturing. Industry, academia, even in the DoD, everybody treats differently. In the Army, they're up to like 13 technologies that fall under the umbrella. In industry, they tend to mean using data to drive manufacturing methods. But within the Marine Corps, we use advanced manufacturing as a larger umbrella to mean both additive and subtractive. Because we've been subtractively manufacturing parts for decades. Our machinists, our 2161s, they've been making parts since the inception of the technology and the capability. But we added to that additive manufacturing. And then we also start operating under the assumption of digital manufacturing, that the data file, no matter if it goes into a CNC mill to be subtractively manufactured or into a 3D printer to be additively manufactured, it starts its life as a data file versus a 2D drawing that you're trying to go through and look at the drawing, look at the machine, turn knobs. And so advanced manufacturing is a wider umbrella that catches all of that technology. That's how we use it in the Marine Corps. Because at the end of the day, if I'm a commander, I don't care how my part gets made. I just want my part.
As long as it's the right size and does the job.
Exactly. As long as it meets the intent.
You, the Advanced Manufacturing Systems team, you fall into the command's Logistics Combat Element Systems portfolio, but that is not where AMS's story began, right?
We're a recent team that got stood up in April of last year because there's 2 entities in Mark Corps Syscom that are doing 3D printing. Down at the Logistics Combat Element portfolio, there was the team that was fielding our programs of record.
Okay.
And so going through the acquisition process is a different skill set than what the other half of the team, the Advanced Manufacturing Operations Cell, was doing up here in the G3 as part of a staff function. So we had 2 entities of one was fielding the equipment, and then the other one was doing everything else besides fielding the equipment. So with advanced manufacturing, 80% of it happens before you get to the machine. So what happens if those 3D printers are largely useless unless you can feed them with data? We need to store the data somewhere. We need someone to go through and manage the process of, okay, Landscorporal designs a part. Is this good enough for use in the fleet? Program offices want to go through and look at advanced manufacturing as a capability to solve issues of, hey, we can no longer buy this part. that is a different skill set than what goes into the program's record at fielding the gear. So we had two entities that were mutually supporting one another of everything that the advanced manufacturing operations cell was doing to support the fabrication equipment program of record team. And then somebody made the call, and it was the right call to go through and, well, we should put these two folks together.
Right.
And so they pulled the fabrication equipment team out of the other entity it was in, pulled the advanced manufacturing operations cell, the AMOC, out of the G3, put them together, and now we have advanced manufacturing systems team. And so now we have a truly one-stop shop for everything advanced manufacturing in the Marine Corps.
All right, and I got to give a shout out because where you're saying, it was in G3, before that, I know that it was in SIAT,
right,
which is now DC SEAL, where the engineers live.
Right.
Yeah, because I remember when it was located in there. So
exactly, yeah. So it started out at SIAT, then moved over to the G3, and now we're actually in a portfolio. And so it's interesting to see the as the capability has matured and the adoption has increased, where does it go and where are we going next? It's always
we're moving the Marine Corps' on-call nerds around the command.
Yeah, exactly.
All right. So earlier you had mentioned that the AMS stores some files of 3D printed parts.
Right.
So how many blueprints roughly would you say are available to Marines, and how can Marines access them to use them?
Yeah. So right now we've got a little north of 500 parts in our digital repository. Anybody who does 3D printing on the hobbyist side, everybody's familiar with the website Thingiverse, which is where, hey, if I want to 3D print something, I can go out and find anything under the sun. Well, the Marine Corps, we need our own repository. I can't go into Thingiverse and hang parts for the javelin. I can't hang ACV parts out there in the open. So we need our own place to park these files. So we have a website called McWorks, and so users can request access. It's CAC enabled. You get on, and that's where the Marine Corps keeps its files. And in there, you'll find, like I said, about 500 files on there right now. It's growing every day, in various stages of maturity. Some of them are still prototypes that are up there. Some of them are approved for use, and you can just grab your part, hang it on your vehicle, and go.
So are you guys the only ones who can add a file, or
No.
if some Lance Corporal designs an amazing thing, can they send it?
We don't want to be gatekeeping on this, and the Marine Corps is largely taking a crowdsourced approach to this. So it's either we can have our 8-9 person team at AMS looking at 3D printing, or we can open up that aperture to the entire Marine Corps. Because the fact of the matter is that Lance Corporal at ground level knows what the problem is, and chances are they know how to solve it. A lot of the PFCs coming in the Marine Corps these days have an experience with 3D printing, either through high school, they did a little bit of college before joining the Marine Corps, they learned on YouTube. $200 on Amazon, you can get a 3D printer for your barracks room, and they're all over the place in there. By going through and opening up to the whole Marine Corps, most of our parts come from the Fleet Marines versus out of my cell or from the program offices. And so, and we want to collect that data. And so if a Marine in Okinawa is having a problem, we can guarantee that a Marine in Lejeune is having that same problem. So we want, hey, there's an upload button. Upload your part. Give us the information. And from there, it determines, does it, for part approval, all right, who can design a part, anybody in the Marine Corps, who can approve use for a part. We've got 2 tracks on is this good to use or not.
It's not the Marine Corps. So we have a program, it's called the Beneficial Suggestion Program here in the Marine Corps. Are they able to get credit for the Beneficial Suggestion Program if they send in a data file for an amazing new widget?
So we have not had anything go through the Benny Suggs, and the best that we can tell is that program wrapped up a number of years ago. So we haven't actually gone through in any of the Benny Suggs with that. I will say that in different parts of the Marine Corps, different commanders are incentivizing this. So one of the things that down at 2nd MLG, the last couple of commanders that came through 2nd Marine Logistics Group have been absolute champions of this technology. And through their innovation campus they have down there, they've stood up innovation challenges to where, all right, every quarter we're going to take Marines and submit your ideas, and then we're going to go through and have a board. And then at the end of the board, there's some of the winners would go through and, all right, you get a NAM at the end of it and then $1,000 cash prize.
Okay.
And so that's how some of our leaders have been going through incentivizing that. And that's the best program I've seen come out of the Marine Corps to go through and do this.
Yeah, I mean, $1,000, that's not chump change.
It's really not.
That's excellent. So if a Marine does have a great idea,
yeah,
how do they contact you? What's the process for them getting implementation?
Yeah, so if you have access to the repository already, there's an upload button on the repository. Now, if you don't, we're completely agnostic as to how it gets to us. We just want your data. So there's a 24/7 help desk in the Marine Corps order on additive manufacturing 4700.4. There's a number. Now, it does go to the officer of the day. It used to be my cell phone number that I had folks calling me at nights and weekends. Just to, it said it was 24 hours. Is it truly 24 hours? Love our chief warrant officers because they will kick the tires and everything. Right. But it'll go to the officer of the day because that's a manned 24-hour line. And then from there, they'll make the determination of, all right, is this something that, hey, we call Matt right now? Or is this something that, hey, next business day, Matt will reach out and we'll go through and we'll start talking. If you email it to us, we'll go through and, all right, hey, what's your problem? Do you have a CAD model that you've designed, but you need 100 of them? Or do you have a CAD model that, hey, it's good, but I need it printed in metal? Or, hey, I've got an idea, but I don't know anybody who knows how to do CAD. Okay, well, hey, we can either do it ourselves or where are you located? There's maker spaces in all of the MEFs. So here's your local resource of, here's other Marines who know how to 3D print, do CAD. Go over to them, and then they'll walk you through the pipeline and get the part up to us.
So how does testing, evaluation, and obviously my favorite, safety, get done on these new parts and concepts?
Exactly. So it's one of those things where it depends on the type and the nature of the part. So not everything goes through the same process. We have 2 tracks for part approval. And so things that are on there like training aids, tools, jigs, test fixtures, facilities items, or anything where the risk in case of failure is so low that it represents no risk of hurting the Marine or damaging the equipment. It's automatically approved. It's one of those things where if you can fix it with duct tape, why would you have to ask permission to go through and do it?
Okay.
And then I'd argue that no good Marine would ever let if I could fix it with duct tape with the printer in my barracks, I'm just going to go do it and I'm not going to ask permission. So if we told them, no, you can't do that, we have to approve it, they're still going to do it anyways. And so we have to provide a way to let the Marines that are going to go through and show that initiative to operate in the light of day with a safety backstop.
Okay.
And so you design your part, it's fast track approved, it's just a plastic enclosure or a button inside the radio that if I pop the battery pack off, the button is spring loaded, it'll bounce out and dump my crypto. Or if it's a plastic washer, but I can't buy this washer, it's in assembly. I got to buy the next higher assembly. Mm-hmm. Instead of this $80 Humvee mirror, I just need a spacer. Those things are automatically approved. Now, per the order, we want you to upload it to the repository because, one, we want to collect all the data.
If one MEF needs it, 2 and 3 MEF are going to need it too.
Exactly. And then the other thing is that also serves as our safety backstop.
Okay.
So my team is in the repository every day. We see what gets uploaded. And if we see something that touches potable water, let's make sure it's the right material. Or that's some load-bearing thing we think. Maybe this needs to go from our automatically approved green bin to the yellow bin, which is our prototyping track. So that's our safety backstop on it. I will say the Marines are really good about it. I've moved more things from our prototyping track to the approved green bin track than the other direction.
So it's funny you talk about potable water because I think safety and non-safety things. Right. So we have food safe materials that we can 3D print as well as.
Exactly, yeah. Okay. So food safe materials, potable water materials. The other things is, hey, look, with this touches a POL. What's this going to do with it? Mm-hmm. Let's make sure that we're not actually going through like contaminating it's a transmission dipstick handle. So
you've been talking a lot about the crowdsourcing coming from Marines out in the fleet.
Yeah.
Let's turn it back here to look inside the command.
Right.
So project officer, team engineer inside one of our acquisition programs here at Systems Command, PEO Land Systems, maybe the Warfighting Lab is doing something, a little more institutional.
Yeah.
What is the best way for them to get in touch with you guys, work with you to be prepared to 3D print parts and components for their system that they're going to field a year and a half, 2 years from now?
Yeah, exactly. So we are agnostic as to when in the system's life cycle you come to us. So if you are milestone A, pre-milestone B in that area, we've got a bunch of things that we can offer you. So some of our efforts that we're developing are software candidacy tools. Okay, how much of your system is 3D printable? We go through, we can load in all the data and then spit out on the other end, hey, like 10% of this is 3D printable using these machines, 20% of it is 3D printable using stuff the Marine Corps doesn't know. Do we want to use that as a metric to go through and drive a decision of, during our analysis of alternative, option A is a little bit cheaper, but option B, we could 3D print more of the parts in the field. We haven't done it yet, but one day we want to start driving requirements to that. But we need a tool that can give us a metric that we can measure against or develop.
Okay.
Some of the other things that we can do is we can offer our data repository that serves 3D printed parts. It's a data repository. We're agnostic as to what goes into it. So, hey, look, we're doing a Seadrill. We want to get data from the OEM. Where do they want to deliver it? Well, instead of putting it on a hard drive on a computer somewhere, we could store it in our repository and date it off so only program office has it. Or also, what data do we want to buy? Do we want to buy, people say, hey, what formats do we want to buy? Or can we buy the native CAD models? Or we can't buy the whole technical data package. What should we focus on buying? That's where that software canvassing tool comes back. If, hey, we should only be buying the stuff that we can action. If a project is a little bit further on and more mature or in sustainment, we get a lot of folks that come to us with DLA 339 issues of, hey, we can no longer source this part. Can we go through and 3D print it?
Reverse engineer the old part, 3D print it.
Exactly. And so a lot of the things that we do end up reverse engineering land on that other approval track, that prototyping track of, we call it the yellow bin, and that denotes it's a prototype. And then we'll go through and we start, all right, develop our CAD model, and then we start going around of what do we need to see before we can approve this. And then eventually things go from the yellow bin of it's a prototype to the unit or the program office can go through and, per the order, prototype for a form fit limited function test until you hit your limit of capability. What do you have locally? And at that point, you kick it over the wall to my team, and that's when we are resourced to go through and collect real engineering data to inform that decision for the program offices or for the commanders that want to use a part. We have ties with Georgia Tech Research Institute, a whole lot of the naval labs, Army Ground Vehicle Systems Center, Carter Rock, Johns Hopkins, Applied Physics Lab. So we can go out, and if you need data to determine if we can use this part, we can collect that data.
So you talk a lot about the data files and sending data files back and forth. There's a cyber aspect of needing to protect those data files.
There is a cyber aspect to it. And now this is one of those things where the Marine Corps is not doing any development in-house on this one because we're going to be dependent upon the industry standards that could get developed around.
Okay.
So a lot of it is there is a aspect to 3D printing where the threat may become more real if there's a man-in-the-middle attack or something gets tampered with. At the end of the day, what it comes down to is it's data. It's ones and zeros. And so our repository is IL4 certified to go through. Industry is experimenting with things like, do you want to use blockchain to make sure there's no man-in-the-middle attacks for it? Our partnership with industry is going to be incredibly important because they're dumping millions of dollars into determining what is going to be the industry standard. And off that, we're going to adopt it. And we're going to make sure it meets our Marcor cyber requirements. So right now, unfortunately, we're in a bit of a holding pattern when it comes to that. And then it comes down to also the part itself of, hey, if we're 3D printing plastic parts that go on the javelin, what's the risk of failure versus if we're printing parts that go on an ACV? Mm-hmm. And so there's different levels of risk with that, which means there needs to be different levels of security that go into it. So that is still a work in progress that we're actively working towards.
Have you had instances where the fleet has come in with maybe almost the right solution, right, but you say, hey, the material you're printing it out of is not correct for that application?
Right, exactly. So we have, all right, we're 3D printing this part. One of them was a water bowl plug. It's printed out of PLA. That's not water safe. You need to just swap it for ABS.
Okay.
Some of the other things what we're starting to experiment with is can we 3D print polymeric rubbers for gaskets? So that's going to be one of those things where now we got to start testing of if I put this 3D printed material, submerge it in my petroleum oil lubricant, whatever it's touching, will it degrade? Mm-hmm. Heat cycles, go through and make sure that the material doesn't degrade. Those are tests that we're working on developing. So this way we can essentially build out a library of, all right, if it does touch potable water, here's the material you need to use. Does it touch 90 weight oil? Here's the material that won't degrade. Does it get hot or, above this material or this temperature inside the engine compartment? Needs to be made out of this material.
And I think that's a distinction that maybe a lot of people don't realize, that when you 3D print out of a material, you do not get all the same material properties as if you had used old school manufacturing techniques with the same actual material.
And that's where we end up using a lot of the expertise that we have, one, in the fleet. Our 2161s are machinists. There are in the fleet materials experts that can go through and look at, hey, no, we can 3D print out a chopped carbon fiber, or maybe I need to go up to a higher grade material like Bolton, or maybe it needs to be printed out of ASA. So these are all types of plastics that don't really mean a whole lot to folks, but they can make that determination. But also, if we need to make that determination outside of the fleet, if they have that question, they can raise their hand and go, I need someone to look at this. And then we can go through and get that data to inform it.
Do you provide training on this? What is available? And do the 2161s, are they the Marine Corps' MOS for advanced manufacturing?
Yeah, so the 2161 MOS are going to be our experts.
Okay.
Because the 3D printing wasn't a new technology to them because they already made parts. They already learned CAD, they learned reverse engineering, they learned how to make it on a CNC mill. But for them, when we gave them additive manufacturing, all the constituent technologies are there. What it was is the file goes onto a different machine. And so they're going to be our experts when it comes down to the metal 3D printing or the high-end stuff or making that determination or if you need a really complex part design. But for everybody else, one of the things that we've decided for the Marine Corps is because it takes a 6-month MOS school to produce a machinist and years of on-the-job training to produce a great machinist. But the barrier to entry for 3D printing is so much lower. I can take somebody who has zero experience, and through our maker spaces that we have in each of the MEFs, so we have Marines teaching Marines basic CAD, basic intro to 3D printing in a week-long course, and we'll take any MOS, any rank. And so we can go through and take those folks from zero to having a beginner-level competency in this. And what that does, it gets us a couple of advantages. It means that, one, 2161s don't have the context around the part. They see a part that comes in, I got to make the part, and I put it back out. But that Marine that requests that part, that generator mechanic, that 1371 combat engineer, that infantryman, they have the full context of what is wrong with the part that the machinists, they don't know or be scared of the Marine Corps. By being able to crowdsource this to every MOS and every rank is that person that has the full context around the problem can take that first crack at it. And from there, if we need to refine it or it needs to be made out of a higher end material, we can elevate it up to the machinist. But also, that means that maybe we don't necessarily need to go to the machinist to go through and make these parts. It can be made at my local level with my capability. And now for the training on that, we do have our maker spaces out in each MEF, Marines teaching Marines on how to go through and do it. But also here at Marine Corps Syscom, we have the Marine Maker Program. We have a mobile training team that will punch out and teach you. This one's more of a creative critical thinking class. So it's based around technology. We'll teach you intro to CAD, intro to 3D printing, laser cutting, basic circuitry, basic electronics, basic programming, and then we'll teach you all these in a week. And we won't make you an expert. We'll go through and we'll teach you enough of it to be comfortable, and then we'll start lobbing at you challenges. All right, here's your end state. Get to it using the tools just put in your toolbox. That's what we do offer. And people see it and they go, oh, it's a 3D printing and programming course. It's not. It's critical thinking. It's problem solving. It's based around the technology. What I'm giving the Marines is better duct tape, better 550 cord, to go through and improvise your solutions using a little bit of code, a little bit of electronics, a little bit of 3D printing, and then give you the green light and the authority to go through and solve problems.
Okay.
On the 3D printing side, on the advanced manufacturing, what it touches on is the tactical level cultural change that starts to happen, that needs to happen in order to make expeditionary advanced base operations work. Is we gotta make Marines critical thinkers, and what that means is there's a lot of times in this training, and my favorite part is that when the Marines' eyes light up of, hey, we just taught you how to, a little bit of code, some circuitry, some 3D printing. All right, go do this. All right, how do you want me to get it done? No, man, that's on you.
Right, figure that out.
And then there's two kinds of Marines. There's the ones that kind of give you that deer in the headlights look of, oh no, someone does the thinking for me. And then there's the other Marines that go, oh, thank God, finally someone's asking me how to think. Right. You got to have Marines that are going to be willing to go through and roll up their sleeves and take a crack at the problem because there's nobody else there.
Obviously, the Marine Corps, as an organization, needs to be ready to fight at a moment's notice, any time and place. But Force Design 2030, we are focusing down on an island-dominated terrain.
Right.
And so what exactly does your team and the Advanced Manufacturing Technologies bring to that fight?
We feel like we bring a lot because we bring a tactical level flexibility to the capabilities that we're putting out there in the Marine Corps. At every echelon in the expeditionary advanced base fight, advanced manufacturing has a role to play. At the very tactical level, that 24 Marines sitting on a remote outpost in the middle of nowhere. We're looking at putting gear out there in the form of the XFAB program of record, but it's 2 3D printers in Pelican cases coming out later on this year. And that is a capability that, look, if you're out there and you don't have your part, everybody talks about, we'll just fly the parts in by drone or send a connector. Every time you do that, you incur risk. You're broadcasting where your folks are. So I need something that can be done on site, and all it has to do is limp me home. And so all it has to do is give me the next 10 miles. Maybe it is a 10-mile part. Well, I got to go 20 miles. Well, I better make 2.
Better make 2 of them, right?
Yeah, exactly. And so I have a place in my repository for those limp-bone parts. It doesn't have to be as good as OEM. And that's out at the tactical level, at the operator level of maintenance. Now, one echelon back at that intermediate level, at dedicated maintenance spaces either owned by the Marine Corps or aboard ship with the Navy, we're going to have less expeditionary, so we're going to have better capability. Larger machines, 3D printers, CNC mills, eventually expeditionary metal printing capability that we're experimenting with. Our counterparts at NAVC are experimenting with printing metal aboard ship. And so as the Marine Corps, I don't care who makes my part, I want my part. So if I need my part and I have my data, pass it back to our maintenance battalions, to the printers aboard the ship. And then they get me a better part that can meet me where I need it, and it's locally sourced. Another echelon of the American industrial base is embracing additive manufacturing as a capability to, everybody knows the supply chain bottlenecks from the last 2 years. One of the things that we've learned as a country is there's nothing virtuous about lean logistics when it comes to needing to be ready to do something right now. It's great for driving a profit, pivots really poorly.
Right.
And so a lot of companies are looking at, hey, can we 3D print these parts in a time of need, to where if I got to pivot my production line, I used to make dashboards for cars. Now I can make PPE for COVID by using 3D printing. You swap a data file versus a whole factory floor.
So now you mentioned the Navy. Obviously, we constantly think about working in conjunction with the Navy. Where do they fit in? Do you talk to them constantly? Say, look, can we print these things on your ships?
Right.
Or can you make sure that you have this amount of capability for us? They probably have some different technological challenges printing at sea in a moving lab, because I know the direction of gravity is important when you're 3D printing.
Well, and that's one of those. So to answer the first part of the question we do interface with the Navy quite a bit. So the Marine Corps has that, internal to the Marine Corps, you have that demarcation line between Marcorps Syscom and NavAir. All of our aircraft are paid by Navy dollars. Therefore, I have a counterpart 3D printing team on the NavAir side that handles the aircraft. And obviously, because there's different levels of risk with flight worthiness,
sure,
they have a very similar process to that. So we talk to our NavAir counterparts regularly, and also our NAVC counterparts. I will say that the guy who's heading up the NAVC additive manufacturing effort, he's a former Marine, so he always thinks of us.
Okay.
And we've got a really tight partnership with this, because everybody, both teams know that eventually the Marine Corps is going to be asking for parts from the Navy, so they're really good about, hey, what do you want? What does the Marine Corps need on which ships? We help inform their experimentation plan on that. So they're experimenting with it on both aboard ship and aboard the shipyard. And you're right. If the printer is moving out at sea at different sea states, what's coming off of it? If you're putting on an aircraft carrier versus DDG, the amount of movement you see on that is entirely different. I will say that NAVC has a harder problem set to solve by printing at sea, because there's that question they have to answer a dozen different times over the different machines and different materials printed on a different boat. But they're coming along very quickly in trace of us, because they know they need to support us.
And lucky for them, they have a Marine leading their effort.
Exactly. And so they've got an excellent campaign of experimentation that's been happening for years. It's moving quickly. We're excited about it. And what's nice is we always have a seat at the table. When NAVC pulls in their community of practice, they always throw an invite out to the Marine Corps. And whenever we're doing anything, we always make sure that NAVC, NavAir, NIWIC, PAC, the other services are in the room with us.
So you talked about TACFAB a little bit earlier. What is XFAB? Is TACFAB a part of that, or are they separate? What's going on?
So XFAB and TACFAB are the programs of record that we are using to field 3D printers, to put 3D printers out into the Marine Corps. So the XFAB is the one that is out there. It's out on the street now. We've got 4 of them out there right now. 5 and 6 are getting ready to come. But that is aimed at the intermediate level of maintenance. It's aimed at our 2161 machinists. So it's in a 20-foot expanding shelter. So it'll wing wall out and go from a 20-foot Connex box into a larger lab. It's got in it 5 3D printers, a laser cutter, a really nice scanner. It's network capable, so it can go through and touch and extend to touch the repository and pull down data. And that's aimed at our dedicated maintenance spaces. Okay. So anywhere where you'll find a machine shop, you'll eventually find an XFAB once you fully field these. And so it's a larger capability with higher-end machines that meet the capability of the machinists. Now, we're on track to, and starting in FY25, put expeditionary metal in those. Right now, it's all polymer. But eventually, we know we need to be able to print metal and print metal in the field. And so Rob Davies, the project officer for that team, is hard at work on that and on that track. That 20-foot box is not mobile enough to suit all environments, and it's aimed at the 2161. So to service everybody else in the Marine Corps, we have the TACFAB, the Tactical Fabrication Kit, and that is going to start being fielded at the end of calendar year 23. And everybody else on the ground side of the Marine Corps, everybody who Mark or Syscom fields to that doesn't get an XFAB is getting a TACFAB. So we've got north of 150 of these things coming out. We're going to be putting 2 3D printers in every battalion or regiment in the Marine Corps aimed at every MOS. And so that feeds off of that intent of, all right, you go out into the fields, you take your 3D printer with you, you can make your local parts, but if you need a higher capability, you just like we do with any other type of part, you reach back to your immediate level maintenance. And then there they have a deeper toolkit of, hey, we have our mobile machine shop, we can either mill the part or we can 3D print the part.
So come into a Marine Corps unit near you, and then they can all go and see it. So
exactly.
It's an emerging technology. I have thought for years that additive manufacturing is both more mature than I think a lot of people think of it, but it is also less mature than a lot of people think of it, because a lot of people think plastics. You've talked a bunch about metals. We can print in ceramics and stuff like that. Yeah. But at the same time, it's less mature because a lot of times there's a lot of post-production that needs done. We don't always get a burnished all-up piece of gear when we're done. So industry, though.
Yes.
Where's industry? What is your relationship with industry? You've mentioned some elements of industry earlier, but just talk to us a little bit about the partnership.
Right. And so 3D printing is more advanced in some ways than people anticipate. Look, we 3D print metal in the Marine Corps. There's 3 metal 3D printers down at the depot. We're experimenting with it in the maintenance battalion. We're on track to put a movable expeditionary 3D printing capability that is metal in our maintenance battalions in the next 3 years. But then also what a lot of folks, expectation management is some people think that, hey, we're going to load up, we're going to push button, receive part, push button, receive the whole vehicle. Like a JLTV is going to roll off the production line. And that is not where the technology is at. The technology will not be there.
It's not Star Trek yet.
Exactly. We're not, 2 Earl Grey hot. We're not quite there yet. Ways away. So we spend a lot of time bouncing back and forth of managing those expectations, but then the technology is constantly moving, and industry is moving at a faster pace than the DoD. And so we have to have tight ties with industry. We do have very tight ties with industry. Our primary tool to get to it is a cooperative research agreement. The reason we do that is it is free for the Marine Corps, so it meets our price point. If industry wants to go through and partner with us to share data on not just ruggedizing machines, because it's a lot more than just the machines, we do have some efforts, cooperative research agreements, to ruggedize 3D printers, because industry's fundamental assumption of, why would you be 3D printing in the snow? Why would you do this in a network-denied environment? Why would you 3D print the back of a moving vehicle? Well, those are all concerns of the Marine Corps.
This is the environment we're going to be asked to fight in.
Right, so. Exactly. Why would you roll this down the side of a mountain? So through some of our cooperative research agreements, we have had companies ruggedize 3D printers. We have had Marines roll them down the side of mountains. And hey, look, it still works. This is great.
Right. So do you do what I would think of as the mil spec or the mil standard 810 type tests on the 3D printers?
We do that on the ones that are going into our programs of record, because going through that testing, it takes time and it takes money. We don't want to test everything under the sun. So by doing this cooperative research agreement, we can act as a filter before we go to that formal testing to meet those standards of, look, we know this isn't going to work because we took your machine, we gave it to Lance Corporal Bonatz, and he did break it. So we're not even going to get to that point. So we use a cooperative research agreement to act as a filter for that. But some of the other things we look at is also the processes. We've got cooperative research agreements with both the Army, the Marine Corps, and industry partners of, hey, what do you do to standardize your material and lock down your processes so you know that when that part comes off the machine, you know it's good? Because one of the other things that we have that industry is moving towards that nobody has yet is that holy grail of qualified, certified parts. And this is where the technology is not as far along as other manufacturing methods. If we have a cast aluminum part in this series of aluminum, we've been dumping molten metal into molds for 4,000 years. So we're pretty good at it.
We know a lot about it.
We know a lot about it. And same thing with forgings and with machinings of like, hey, we know the billet's good before it comes to us. So if we mill it, the part's going to be good. Industry's not there. We don't have professionally accepted standards for additive manufacturing, for advanced manufacturing, like we do with these other manufacturing methods. So we have cooperative research agreements with industry to go through and, hey, what are you guys doing? How can we inform this? Is this something that we need to do at the depots, or is this something that we could get to a technician level and maybe one day put in a maintenance battalion? So we're partnering on not just the printers, but also the processes. We have a great relationship with the 3D printing industry. Now, what I will say where we need to get better and where I want to get better is with our OEMs that aren't on the 3D printing side. So one of the things that NavAir does and that I want to take for the Marine Corps is they have a great relationship with their OEMs. And so what they're doing is they'll do a cooperative research agreement with an OEM. So they'll pull in company X that makes this piece of aircraft, and then they'll pull in NavAir and some of the labs, and they'll pull in company Y that does 3D printing, and they'll all go through and do a cooperative research agreement to share data of, hey, look, I don't care if the OEM 3D prints my part. I just need to make sure that you can make my part today, tomorrow, and forever.
Right.
And so I want to start doing that with our OEMs here. Can we pull in, a program office, pull in their OEM, and then my team can come in as the advanced manufacturing SMEs, pull in some of our industry partners from the 3D printing side, and can we go through and start working on these problems so we all mutually benefit?
So we talked about the Navy a lot.
Yeah.
What about the other services?
Yeah, so the other services are, everybody's hot and heavy on advanced manufacturing. I will say that we interface with all the other services on a regular basis. Even just this week, we're meeting with our Army counterparts. So we partner really well with the Army because while we're part of the Navy, we share a gear set with the Army. And then on the Air Force side, we partner with them a lot because they like working with us because we are able to accept more risk because of the nature of our gear. And so we can move a lot faster. So we have a really good relationship with the Air Force in that they bring a lot of the hard science and tech to us, and then we can move at speed. And so we have great relationship with the other services. And I will say the Marine Corps is only able to move as fast as we can on this because I know the other services are coming behind me with their organic research base behind them. Their in-house scientists, their in-house labs. We work with them quite a bit, and I can move fast and take risks because I know behind me I'm informing the risks, and they're moving at a slower pace, but they're bringing a lot of dollars, a lot of mental acuity to the problem to solve them because I can sort something out and go, no, that's a cul-de-sac, don't go down that one. Hey, this is useful. Can you guys please look at this for us? And we have this really good symbiotic relationship with the other services.
What about with our allies, international partners, NATO, etc.?
Yeah, so we have that as well. Even just this week, I was interfacing with our British, the UK Army counterpart and our Australian counterparts. So we've all realized that this is a problem that's not going to go away, and we need to be able to mutually support one another. If a Marine Corps unit is working with an Australian unit, we need to be able to repair each other's equipment. And so what this comes down to is, all right, what type of 3D printers do you have? Can you support me? What type of 3D printers do I have? Can I support you? And we can do that with CNC and with additive manufacturing better than we could do with traditional factory methods because we can fix at a forward area. We just got to be able to share data back and forth and also understand at what level can your commanders accept risk and what level can my commanders accept risk. And so that's some of the things we're working with our other allied nation partners. And I will say outside of that, the XFABs that we have fielded to 3MEF, those things, the Marines that own them have been doing a great job. They have brought them out to joint exercises with the Japanese Ground Self-Defense Force. We have one of them right now that's on the ground in Korea for an exercise. So talking to our allied partners, showing, hey, here's what the Marine Corps is doing. Here's where we intend to go. Come with us.
So as our long-term listeners know, last year we had Manny interviewed Dr. Kristen Holsworth, who's the chief scientist with your advanced manufacturing. And they specifically talked about a 3D printed boat that, what was going on, University of Maine?
Yep.
So what's the status on that?
We have 3D printed our vessel, and then we took it from Maine and drove it out to Amphibious Vehicle Test Branch, another Marine Corps SysCom entity, put it in the water, and we did sea state testing. We did open water testing. We did beaching testing. Hey, let's drag this thing up onto the beach and see what happens. Survive. Flying colors. And so that's the current state of it. Now, we proved out that, hey, we can print a vessel. It can carry 2 20-foot ISO containers. We could tow it through the water. We could tow it in the open ocean. We could drag it aboard the beach to go through and get the things off of it. What's next? And so next steps is on our next iteration, we want to go through and advance that. So right now it's all towed. So can we go through and put a power pack on this? Can an outboard motor? Can it self-propel? Can I do a roll-on, roll-off capability? That's the next questions we want to answer with next year's effort.
Okay.
And then beyond that, long term, eventually I want to go through and build out a library of capability of, hey, if I got to move this type of equipment this far and this speed, I just, all right, plug those in and here's my library. And hey, I've got a thing that moves small amounts of gear very fast, very far, very efficiently. Or I got a thing that'll move a larger amount of gear a little bit more slower, but that fits my mission profile to where I don't need to make all my connectors look the same.
Mm-hmm.
I can go through and swap files in the machine, and then that machine bangs out something that I need for my mission, and then we can move on.
So even on YouTube, I can go and I can find videos of 3D printed buildings and such using like a concrete printer. So where are we with that?
And so we're also experimenting with that in the Marine Corps because we know as we need to get lighter and logistically smaller footprint in support of EBO. So I'm a combat engineer by trade. So I will say as we go through the two communities that have the most to lose in the transition over to expeditionary advanced base operations is one the infantry. What is a rifleman doing in a guided missile fight? Then two is the combat engineers, because all my critical assets and everything, bulldozers aren't going ashore. My bladed assets, my dozers and everything, my materials handling equipment, those are all big things that go through, but they're too big, but they're critical for the capability. And also the labor and the materials that go into doing any kind of construction of my 40-man platoon would roll up with trailers full of lumber to go through and build concrete formwork, dump in the materials. You're not going to have 40 combat engineers in any one place. That's a very rich target. What we're looking at for concrete printing of structures, of expeditionary structures, can I go through and take out, instead of 40 Marines bringing in lumber to build formwork and go through and dumping in the concrete, can I take a machine that is smaller than a bulldozer, smaller than a tram, or front end loader, and get it small enough, light enough to where it packs into an ISO container, and then I can have 4 general purpose Marines. Maybe one combat engineer knows how to operate it, and then just 3 other cats to go through and babysit the machine, feed it.
Give me an 0311.
And then now we can do the work that used to take a heavy equipment section and a platoon of Marines to go through and build these expeditionary structures. Can we do that in a way that meets the Marine Corps environments? We're still experimenting with it. And so we're trying to figure out, does this fit in our portfolio? Does this fit into the CV's portfolio? Because they support us. And so we're experimenting with that. And we're also experimenting not with just the machines themselves and the form factors. We need to be able to print bigger with smaller machines, but also I got to be able to feed in local feedstock. If you're developing a machine that you own the super sack, well, I'm not going to transport that super sack from California out to Southeast Asia. I need to be able to find local materials, feed it in the machine. Can it come out the other end? And so we're looking at a lot of the materials that we're feeding these, not just the machines themselves.
A lot of our listeners are Marines, and so I think a question that's very interesting to them is, are we capable of printing a rifle?
Yeah.
Something smaller? Can we print bolt carrier assembly?
Yeah.
What can we do?
While we can, it is technically capable to go through and, if bolt carrier groups, you print those down at our industrial printers out in Albany. But the fact of the matter is a lot of those are some of the most prevalent pieces that you have in the Marine Corps, having a really robust supply chain. So in the Marine Corps, we're not doing a lot of 3D printed firearms because I don't have a gun problem. The problem I have is I've got a truck that was built in the 80s and then half the manufacturers went out of business. Mm-hmm. And so people are like, the Marine Corps is not printing machine guns. No, we're looking at readiness elsewhere. So while we're technically capable, we tend to not, because there's already a really robust supply chain going through on those parts. They tend to be some of our most modern pieces of equipment.
Is there a problem in the Marine Corps that you think 3D printing could just lean right in and solve a problem, but we're not doing that right now?
Right now, everything that we go through, we put on a injured Marine, an injured sailor, has been through an FDA approval process. Mm-hmm. But one of the things that we know that in the EBO environment, that golden hour is going away. One of the things that we haven't looked into yet, and we intend to start looking into this in the future, is at what point can we accept the risk of, hey, these 3D print parts, they might not necessarily be sanitary or they might not be FDA approved, but is that a better option on there? So where there's a technical piece of, hey, what can you 3D print out of this medical kit? And then there's an authority piece of, who can make that call? I'm willing to assume the risk of, this is not this didn't come out of an FDA approved process, but this injured Marine has a far, far worse problem than that. We're staring at, it's that trade space. If I have an immediate problem that I can potentially solve, we haven't begun to look into that. That's a really complicated thing. NATO's starting to look into it, and we intend to work with NATO on our NATO counterparts on sharing data. Who's the furthest ahead in this? Are those processes and procedures that we can adopt as the Marine Corps?
We leaned in and we're helping to print some parts for ventilators a couple of years ago in support of COVID relief, right?
Right. So we did that. So we looked at early on ventilator parts, a lot of PPE that was made. And the analogy we used on that one was the many small boats at Dunkirk. So when COVID caught everybody entirely flat-footed and the supply chains broke down, things that could pivot the quickest was the advanced manufacturing technologies, the machines and processes that are agnostic as to what they're making. And so we were able to pivot very quickly as a holdover while larger industry spun up and was able to go through and answer that. That's a great use case for advanced manufacturing while larger industry pivots and they can bring the mass and volume that you need. You don't see any more 3D printed PPE because our production lines for PPE are set up.
Caught up.
Exactly. You don't see any more 3D printed ventilator parts because the production lines have pivoted. But in those critical first few months, we're able to go through and lay out, all right, those doctors in the hospital who can assume the risk of, oh, look, I need this part now or this person's going to die. And that was a different decision-making process in an emergency than we face today. The same approval process applies to the Marine Corps. You're going to make a different decision if you're in the RUQs or if you're in Garrison and Camp Lejeune.
What has been the coolest, most exciting thing that you've been involved in printing?
Personally, I was involved in helping our program office for the Javelin reverse engineer a bunch of parts on it. So that command launch unit.
Okay.
That thing's mostly polymer. So you can go through and what on this could we go through the 3D print? Because we knew that it was January of last year. Boy, things are kind of getting a little weird in Eastern Europe. We probably know that this piece of gear is going to play a critical capability, and the production lines on it tend to be slow for good reasons. Complex system. What can we make on this one in the Marine Corps? So that was me personally that I've been involved in. The thing I enjoy the most because we immediately saw real world effects of, hey, we got to start going through and supporting allied nations with our equipment capability, and all of a sudden our production supply chains are in flux. Well, there's certain things we don't need in a certain order because we can make them in-house. Within the AMS team, some of the coolest things is I love the fact that we beat all the other services to the punch on fielding our programs of record first, and we're getting ready to do it again with our second program of record fielding the equipment.
Okay.
I love the fact that we were the first service to go through and 3D print vessels. And so that one is, I'm a petty person. I'll lord it over my Navy counterparts of, hey, we printed a boat before you guys. And then like, hey, that's not a boat. It's a rectangle that floats. I got you. And so we've done a lot of firsts. And then the other big thing that I'm most proud of is what the Marines come up with. You know, every day I see parts that who's involved in the process of the other services. A lot of times it's their organic industrial base. They're career civilian scientists, they're engineers. Whereas in the Marine Corps, the Fleet Marines are actively involved.
We're crowdsourcing it.
Exactly.
Right.
The best part of my day is when I jump into the repository and see what's come through, and it is Lance Corporal so-and-so, Corporal so-and-so, designing a part, and we're solving our own problems. We're more than capable of doing it.
I imagine you're pretty similar. So if we come to your garage, are we going to find a whole bunch of toys?
Yeah, absolutely. So there's two 3D printers in my basement. They run darn near around the clock. A lot of times it's, hey, look, I do a lot of woodworking, so I'm making custom jigs for my stuff. Or I'm fixing the dishwasher for or hey, look, we need to go through and I don't like the way this is working on my house. I'm going to make my own thing. Or printing toys for my daughters or toys for myself. So yeah, there's 3D printed parts all over my house, both a functional and a play aspect. Because the barrier to entry is real low. $200 Amazon and a little bit of YouTube, and you also can get into it.
I'll need to go home and talk to my wife about that.
Oh, yeah.
She won't want me to have another hobby.
The first time I went through and fixed something in the house that paid for the cost of it, I immediately like, okay, I see why we got this.
Excellent.
So,
She wants the benefits at home. So
exactly.
What advice would you give any young Marine or anyone else who is interested in getting into advanced manufacturing?
Get involved with it. Try your hand at it, and then from there, it's the aperture opens up of, oh man, all the things I can go through and solve with this. It's a very low barrier to entry to making things. Before steady hand and a Dremel, hot glue gun, you need to be a really crafty person. This kind of changes the dynamic. So
what do you recommend for any Marine who wants to get into acquisition?
I will say that the acquisition piece, the hardest part that I struggled with was the definitions. One of the things that I found out that there's a website called ACK Notes, so Acquisition Notes, and they've got a great dictionary. And the first year I spent, had a tab permanently open on my web browser for the definition. So, all right, we just said a trap. All right, what's a trap? And go through it. The hardest part on it is learning the language. And so having tools like that through DAU, through ACK Notes, you can immediately punch it in and learn, all right, here's what it does, here's what it means, here's where it fits in the process. That was the hardest barrier to entry.
Well, Matt, I got to tell you, I really appreciate your coming in today and having what has been an amazing conversation. I hope that all the listeners have learned a lot. But we do have a thing around here we call our lightning round. Are you ready to answer the lightning round questions?
Let's do it.
All right. So when you were a child, what did you want to be when you grew up?
Batman, for longer than it was socially acceptable, too.
So that is a very popular answer amongst the 8-year-olds.
Right.
Nice.
Right, yeah.
I will say that my son, a number of years ago, pointed at a Marine on TV and said, "Superhero Daddy." And I said, "Damn right, superhero." So
there we go.
Good call. All right, so if you could have dinner with any historical figure, who would it be?
Carl Sagan.
Carl Sagan, nice choice.
Yeah.
Scientist, author, good call.
Yeah, absolutely. The insights that he offers on everything. And one of the things that always impressed me is he managed to find beauty in every mundane aspect of everything. I really like that outlook.
Do you have any tips for maintaining a work-life balance?
I should be on the receiving end for this one for work-life balance. But I will say the most important thing is you got to unplug, especially in a space like this where it's such a target-rich environment. You can work 24 hours a day and not get anything, or not get to everything on your to-do list. So there's a point of time where I unplug, the laptop gets shut, phone goes face down, and then I walk away from it all. That's important for me because downtime is an important part of my creative process. I've learned that about myself, and luckily I got a 4-year-old daughter who keeps me accountable on that.
What is a TV show, book, movie, or podcast that you'd recommend?
Yeah, so on the book side, fiction, big fan of The Martian by Andy Weir, and then another book by Andy Weir called Project Hail Mary.
So I can't recommend enough. I think a lot of people have watched the movie The Martian,
right,
which is on my I'll watch anytime list.
Yeah.
But this is a classic case where the book is better than the movie.
Right, and I loved the movie. Great movie, but there's 8 or 9 more wicked problems that he solved in the book, and the book does a great job of walking through his process more than it just wouldn't translate to the screen.
Imagine how much better he would have been if he'd had some 3D printing capability on Mars.
That is one of those things that I did notice. It's like, and then on the nonfiction side, everybody out there in uniform, you got to sit down and you got to read Neptune's Inferno. That is the most. That's one of those things that book kept me up at night. It's a look at the Guadalcanal from the Navy's side, and the pertinence of the problems they solved. Oh, we're going to have these exact same problems. The decisions that the commanders made. Another great book that I can't recommend enough.
Well, good. I appreciate your answers. I appreciate your coming in and just having this whole conversation. And
absolutely.
Best of luck with helping the Marine Corps do this whole 3D printing, additive manufacturing stuff.
Thank you very much for having me. I've really enjoyed my time.
This concludes another episode of Equipping the Corps. I hope you've enjoyed our conversation today. If so, please take a couple minutes to leave us a review, subscribe, and tell your friends about us. Until next time, stay safe. This is Tripp signing off.